students. After knowing Henry's law, today we will complete very important topic, Raoult's law. So Raoult's law has two parts for volatile solutes and for non-volatile solute. Before I start you explaining Raoult's law, I will first explain you two important terms, that is vapor pressure and volatile substance. So what are volatile substances? The substances which forms vapor in room temperature. At room temperature, if they are forming vapors, they are called volatile substances. Like in our daily life, we see Vicks. Vicks is the volatile substance. When we put Vicks in hot water, it forms vapors. So both water and Vicks forms vapors. So we can consider Vicks as volatile substance. Petrol is very much volatile. You all know. Like nail polish remover, that is also a volatile substance of daily use. So the first is volatile substance, and the second important term is vapor pressure. So what do you mean by vapor pressure? Think of that. As the term indicates, it is the pressure exerted by vapors. So how will we measure this vapor pressure? Suppose if we are taking water in a container and this water is forming vapors. So these vapors will escape out if the system is open. So first we have to keep the system closed. We have to make the system closed. So in the closed system, what will happen? The water will convert into vapors, and when these vapors will exert pressure over the top layer of liquid, that pressure will be called vapor pressure. So it is the pressure exerted by vapors on the surface of liquid. Now, very important thing to keep in mind, that when do we measure this vapor pressure? Suppose if I have just kept this water here and few vapors are formed here, so I will not measure the vapor pressure because there are very few vapors. I have to wait to measure vapor pressure till the system attains equilibrium. Equilibrium means H2O liquid will be in equilibrium with H2O gas. It means the amount of water converting into vapors will be equal to the amount of vapors converting into liquid. So we have to wait to attain that situation, and whenever that situation comes, whatever the pressure is exerted by vapors on the surface of liquid, that is called vapor pressure. So this thing is very important because we are all going to understand this concept on the basis of vapor pressure only. So now see, very important term, that vapor pressure, Raoult's law for volatile solute. Now, if yesterday I told you that in our class 12 syllabus there is only binary solution. So binary solution has only two components, one is solute, one is solvent. So today we are discussing the solution which is having solute as volatile, and we all know that solvent is always volatile because we are taking universal solvent water. So if the simply Raoult's law says that the vapor pressure of each component. So if the solution has two components, A and B, yesterday I told you A for solvent, B for solute. So if both the components are volatile, then the vapor pressure of component A will be directly proportional to mole fraction of that component in the solution. So I think it is clear to you all that Raoult's law for volatile solute says that vapor pressure of each component is directly proportional to mole fraction of that component in the solution. Similarly, we can write this PB, that is vapor pressure of component B is directly proportional to mole fraction of component B. Now, when we remove this proportionality sign, we have to put one constant. Now see how am I writing this? This is vapor pressure of component A, that is equal to, see now how am I writing this? P naught A. See the difference in P naught A. This is the vapor pressure of component A when it is taken in pure state, means when no other component is present in the solvent. So PA naught into XA. And why this is the small p? Because you all know that when we talk about mixture and when we talk about pressure in the mixture, we always take partial pressure, not the pressure. So this is the term denoted like partial pressure, but here it is P naught because it is the pressure of pure component A. Similarly, we can write partial pressure of component B equals to pressure of component B in pure state, of course vapor pressure of component B in pure state, and its mole fraction. So it means if you have to understand this concept in your daily life, you can understand the two experimental conditions. Just take 2 glasses and take 100 ml of water in these 2 glasses. Now, what you can avail at home, that is Vicks or the liquid medicine which you take during steaming while you suffer from cough and cold. So suppose if you are taking the liquid medicine and if you can measure its amount that you are putting 1 ml of that liquid medicine which is volatile. So now according to Raoult's law, what it says that the vapor pressure of medicine, how much vapor pressure is produced by medicine will be directly proportional to amount of medicine present in the liquid. And suppose in the second case, if we are taking the 100 ml of water, but now we are putting 2 ml of liquid medicine, so the vapor pressure produced of course will be more of that medicine because its amount in liquid is more. So it is very simple law that when both the components are volatile, so their vapor pressure will be directly proportional to their mole fraction in the solution. So this is very important law. And when we combine these two, because when we talk about the pressure of mixture, we have to get the total pressure. And whenever we talk about the total pressure, and we know that total pressure equals to partial pressure of component A plus partial pressure of component B. We all know this is not Raoult's law, this is Dalton's law which we studied in class 11th. So P total equals to PA plus PB, and we can replace this partial pressure of this. So here in class 12th we will use this formula that for a binary solution containing both the components as volatile, then the P total will be, that is P naught A into XA plus P naught B into XB. So you all know that we can get the total vapor pressure of the mixture. So this is Raoult's law for volatile solute. I explained you the daily application, daily life application, that if you want more effect while steaming, means you want to increase the content of medicine in your steaming, then what you should do, you should take the lesser amount of water and little bit more medicine, so that you can get more vapors of medicine, because when the more liquid medicine is in the liquid state, you will get more vapors according to Raoult's law. So it is daily life application. Now we will move to Raoult's law for non-volatile solute. I think this is visible to you all for non-volatile. Now, if I ask you that what is non-volatile solute, you just imagine in your mind any one example. So you will definitely think of common salt or glucose, which does not vaporize. So now see what happens when we dissolve. If we take water, its upper surface will contain all the molecules of water molecules. And what is vaporization? You all know that the upper molecules will convert from liquid to gaseous state. This is vaporization. Always the sulfur molecules participate. They convert into vapor state. Now just consider that if I add 1 teaspoon full of NaCl in it. Now think what will happen, because NaCl is non-volatile solute, so some of the surface area will be covered by these non-volatile NaCl molecules. They cannot be converted into vapors because they are non-volatile in nature. Now see, because some of the surface area is covered by non-volatile molecules. Now the surface area reduces and the vapor pressure will, of course, the tendency to convert into vapor will also be reduced. So on adding non-volatile solute, the vapor pressure will reduce. So this is the another aspect of Raoult law, that it says when a non-volatile solute is added to a solvent. So of course, when a solute is added to solvent, it is no more solvent, it will convert into solution. So it says that the decrease in vapor pressure. Now see how to express the decrease. This is the vapor pressure of water, because you all know that vapor pressure in pure state is always considered as P0. So this is vapor pressure of solvent, which is in pure state, and this is the vapor pressure of solution, S for solution, S for solution. So you all now can understand why not PS minus P0. Why? Because P0 will always be greater than PS. Why? Because I told you P0, when there is pure water, the surface area is larger, more molecules are converting into vapor phase. But when NaCl is added, some of the surface area gets covered, blocked, and lesser molecules are converting into vapors. So the vapor pressure of solution PS will of course be lower than P0. So if we are saying that lowering in vapor pressure, so we have to say P0 minus PS. We cannot write PS minus P0. So this is, so it was observed that lowering in vapor pressure is directly proportional to mole fraction of solute. So this B, yesterday I told you that B is the symbol for solute, A for solvent. So lowering in vapor pressure, कितनी कमी होगी वेपर प्रेशर में, वो सीधा सीधा किस बात पे डिपेंड करेगा, आपने कितना नमक डाला है. आपने 1 चम्मच नमक डाला होगा तो वेपर प्रेशर कम होगा, आपने 2 चम्मच डाला होगा तो जो कमी होगी वो दुगनी होगी. So lowering in vapor pressure is directly proportional to mole fraction of solute added. And if you have to remove this sign, you have to put one constant, and that will of course be P0 again into XB. Now if we bring this P0 here, we will get a mathematical expression, PS upon P0 equals to XB. Now I will explain you the two basic difference. See this. The term P0 minus PS is called lowering in vapor pressure, while P0 minus PS upon P0 is called relative lowering in vapor pressure. I will explain you it with some numeral value, like if I say that, suppose if the vapor pressure of pure water is suppose 100 mmHg, and after dissolving sugar, 1 teaspoon salt in it, vapor pressure of solution becomes 80 mmHg. Of course the vapor pressure will reduce, no need to say again and again why. So this will be reduced, and if I say what is the lowering, what is the value of lowering, so of course you will say that lowering is 20 mmHg. So this term is the lowering of vapor pressure. But if I say what is the relative lowering, so 20 lowering out of what? 20 lowering out of 100. So if you say that there is a lowering of vapor pressure 20 mmHg, so everyone will ask from what, which amount? So that is 100. So this term P0 minus PS upon P0 is called relative lowering in vapor pressure. So see, we can explain, we can state this law in two ways. Now I am stating the first way. The lowering in vapor pressure for a solution containing non-volatile solute is directly proportional to mole fraction of solute added, or the relative lowering in vapor pressure of solution containing non-volatile solute is equal to mole fraction. So here it is proportional to mole fraction, it is equal to mole fraction, it is lowering in vapor pressure, it is relative lowering in vapor pressure. So if you say that I scored 17 marks, so everyone will ask from what number? So if you say that I scored 17 out of 20, so these are good marks. If you say that 17 out of 50, so you are getting just passing marks. And if you are saying 17 out of 100, so it means this is the failing marks. So by this way, if we are saying that this is the lowering in vapor pressure, then if you are expressing from how much amount, so from lowering from 100, so that would be the concept of relative lowering in vapor pressure. So these are the two laws, and now I will explain you the daily life application of this law, the solution containing non-volatile solute. Now see what happens. You must have seen that in Missouri there are so many egg sellers who are selling their eggs on this mall road and all. So how they boil their eggs, because when we used to boil the eggs at home, what we find that if you are keeping the 12 eggs, the 1 or 2 may get their shell ruptured because when the eggs are boiling, the excess of steam may hit the shells and may rupture the shells. But what these people do, because they cannot afford this much wastage, that will bring economic loss to them. So what they do, they boil egg in the water containing salt in it. They put excess of NaCl in the salt, they make the salt solution, and then they boil the eggs there. So what happens when we put eggs here, there would be lesser vapor pressure generated, and this vapor pressure will be sufficient to cook the eggs, but this pressure is not sufficient to rupture the shell of the egg, so they can control their economic loss. So this is the daily life application, that how we can control the vapor pressure of any solvent by adding a suitable non-volatile solute in it.